Titan is an amazing world. Not only is this satellite of Saturn one of the largest such bodies in the solar system, second only to Ganymede in size, it has a fairly dense atmosphere. But that's not all. It's the only place in the solar system other than Earth where a hydrological cycle exists, albeit radically different from Earth's. I use the term hydrological, realizing that it sounds a bit incorrect. As what the correct one is, I don't know. On our planet, this cycle is a sequence of processes to change the state of water. But it's not like that on Titan. It's very cold there, averaging about 180 degrees Celsius frost. This means that the hydrological cycle on the satellite is not based on water, but methane and ethane, which at those temperatures behave like water at room temperature. In this exotic or even strange to us, of course, clouds of methane and ethane form in an atmosphere made up mostly of nitrogen. And out of them eventually fall raindrops that can fill lakes and seas, canals, ditches, and aqueducts full of titanium fish and magnificent purple crayfish served in Martian hotels with Venusian carnivorous mushroom sauce. Just kidding. This hydrological cycle is quite valid to compare to Earth's, because even though we have very different worlds to analyze, this process is capable of changing the landscape in a similar way. This, of course, does not mean that different processes cannot occur on Titan than on Earth. But overall, we have more in common than differences. The arrival of the Cassini probe in the Saturn system has revolutionized scientists' knowledge of Titan, because previously the distance from the satellite to our planet and its surface, constantly covered with a haze of organic compounds, did not allow to know what is happening there under this cover. Now much more is known about the surface of Titan thanks to data from the Cassini radar, which scanned the surface of the satellite in the radio band. There were also images taken in certain optical windows at those wavelengths in the optical range that allowed us to see some details of the surface. In 2014, a team of scientists published a report on the discovery of a new island in the Sea of Ligeia, the second largest body of water on Titan, located in the polar region of the northern hemisphere of the satellite. This was the first time in history that scientists had observed a dynamic fluid phenomenon on another space object. But they had legitimate questions. Where did the new island come from in the first place? Why wasn't it there before? What caused its appearance? The first hypotheses suggested that the object was an illusion, and that it is just an optical effect caused by the reflection of radar waves from the turbulent surface, or the presence of gas bubbles in the liquid rising from the bottom of the sea, or some pieces of solid organic compounds that begin to float when heated. And even the real appearance of real new islands for various exotic reasons was also voiced as one of the versions. However, some very strong preferences for one or another option scientists have not formed. After all, they saw such a thing for the first time. And now, recently, in the journal Geophysical Research Letters, was published a study which states that the appearance of mysterious islands on Titan is actually largely due to the processes occurring in the atmosphere of the satellite and chemical reactions that occur in its seas. It is these that generate the solid materials that accumulate on the surface of Titan's reservoir. These solid organic compounds, according to the authors of the article, occur near the coastline and over time may well form icebergs capable of break off and float on the seas of Titan. This process is very similar to the way the destruction of polar glaciers on Earth. These floating masses stay afloat for a while, but little by little, their pores become saturated with liquid and they gradually sink into the depths, in the same way it happens with pumice, a rock of volcanic origin, on Earth. It floats at first, and sometimes people see it in large quantities on the surface of the ocean. But as the pores of the pumice fill with water, it slowly sinks into the water. The study also focuses on a very important detail that until now had no clear explanation. Why do Titan's seas have such a smooth surface with no visible waves? The authors of the work suggest that this condition may be evidence of the existence of a layer of frozen, solid organic compounds covering the surface of the seas of Titan. If all goes well, we will be able to find out if the hypothesis expressed in the study after the mission Dragonfly will arrive on Titan in 2034. Its launch is scheduled for 2028. Thank you for watching this video to the end. Don't forget to like and subscribe to the channel to learn more about space.